Okay, finding the angle between two vectors. Now this one's probably going to take a little more thought. So first off, let's look at it. The angle between two non-zero vectors is the angle theta, which will be between 0 and pi, between the respective standard position vectors. This angle can be found using the dot product. Basically, the big thing you need to recognize is, why does it have to be between 0 and pi? Well, think about it. In triangles, can you have an angle larger than 180? And remember, pi is equal to 180. So it makes sense that the angle has to be between those two values. And no matter how you draw a line, one side is going to be between there anyway. So let's take a U and let's take a V. Now let's think about this for a second. What would happen if I had a negative U and I added it to the end of the V? Now notice, this, if U goes this way, negative U would go the same distance that way. I'm just adding it to the end of V, just for picture purposes. And now I'm going to draw one from there to there. Well, that's the same as V in a sense. What? Minus U puts me at the same point. So vector V minus U makes this triangle right here. Now I'm wanting to find this angle in here, right? Well, think about it. Guess what this angle will be equal to? Dun, 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 dun. Right there. I can move it simply right up there. So if this is U and this is V, that would be vector V minus U. Okay, it's real important, because now what have I made? I've made a triangle. That's what, right? I've made a triangle. And now I want to find that particular angle theta between U and V. And notice this V minus U helped make a triangle here. So this is what we know. If angle theta is the angle between two non-zero vectors, U and V, then the cosine of the dot product U times V will be equal to, in a sense, the magnitude distance of U times the distance of V. Think about it. It's like, so finding the angle between the two vectors, here we go. Suppose U is 4, 3 and V is 3, 5. There we've got a nice picture. We want to get that angle right in there. All right, so we can see that. That's the angle we're going to mess with. And let's go to our formula. So the first thing I need to do is plug it in, plug it in. Notice I'm putting the dot product there, the U, the 4, 3, the 3, 5, and then the magnitude of those, which is the same thing as this, the 4 times that 3, plus 3 times that 5. And remember, this is like the distance formula in the square root form, 4 squared plus 3 squared, and here 3 squared plus 5 squared. Now let's think about it. 4 times 3 is 12, 3 plus 5 is 15. 4 squared is 16, 3 squared is 9, makes 25, the square root of 25. That's 9 and 25 is going to make 34. Uh-oh, hey, what's the square root of 25? 5. And 12 plus 15 is 27. So therefore, that's not cosine theta. It's basically my arc cosine theta. Now remember, to do this, if I want to actually find what theta is, I go to second cosine on the calculator. Second cosine, because it's arc cosine, and put in parentheses 27 divided by, and you need to put the 5 times square root of 34 in parentheses in order to get this right. That would need to be in parentheses on your calculator. And if you do, it's going to be about 22.2 degrees. That's how you would actually find the angle. Basically, you're going to multiply the vectors and use the distance formula of each vector, and then do second cosine. That's what's involved. So, what have we learned today? Dot product, multiplying the first and the last and adding them together. There's no outer and inners. The properties of dot product, they seem pretty standard, like most of our associative properties and distributive properties. We learned about dot product and magnitude, and how we can use those to find the angle between two vectors. So that's what we're going to do today. And here's where we're going to do it. It's going to be a shorter assignment, page 429, just problems 1 to 22. And remember, I'll be around to help, and looking forward to it. We hope you all have a great night.